Everyone, it's me, Mona. So I decided to put together a stoichiometry roadmap for you guys. I know some of you are still struggling with stoichiometry, so I hope this tactic will really help you um, finally start to understand it, and it'll be that click that you need to solve problems on your own. For those of you that like my method of doing the figures, so if I have carbon, he has 1 mole, and if I put him on a scale, he weighs 12.01 grams. Some of you may like that method, and if it works for you, great. Keep at it. If that method is still iffy, I really urge you to look at this roadmap and see if it works for you better instead. Again, if the figures, carbon, the mole, putting him on a scale works for you, then you can go ahead and X out of this video so you don't get too confused. All right, so I'm going to go ahead and jump right into it. So I have substance A on my left side right here. He's in pink, okay? And he's friends with substance B, who's in green on this side, okay? But they live cities apart. So in order for substance A to visit substance B, he has to cross this bridge, okay? He'll cross over this bridge, hit the yellow dot, and he'll be in B's city. Similarly, if B wants to visit A, he must cross over this bridge to get to substance A. All right, so let's first visit the details of substance A. Okay, so substance A has massive element, molar mass, moles, molecules, and atoms or molecules. Okay, so what does that mean? Well, let's say a problem gives me 3 grams of aluminum, for example. Okay, 3 grams of aluminum. So my units is grams, so I know this is mass. And it wants me to convert 3 grams of aluminum to moles of aluminum. So I would start here. I would go ahead and work my way up to this yellow dot. But notice there's a pit stop, okay? So I start here. I have to make a pit stop. And my pit stop tells me I need to find the molar mass of aluminum for my periodic table, okay? So if you get your periodic table, you'll notice that aluminum has a molar mass of 26.98 grams per 1 mole. So I'll go ahead and put that information in my table, and then I'll move on until I reach my destination, which would be moles. Okay? So in order to find mass to moles, I would move this way. Moles to mass, I would move this way. Similarly, atoms to moles, I'm going to move up. If I want moles to atoms, I'm going to go ahead and move down. Okay, so I can either move up, move down, move up, or move down. If I want to go from massive element to atoms of molecules, do you think I could just jump over? There isn't a road here, so you can't just jump over. I'm going to have to go up the road to the yellow dot and then down all the way to the end of the arrow. Okay? Same thing with substance B. I can either go up or down or up. If I want to go from atoms to mass or mass to atoms, I have to go up or down, up, down. Okay? And if I want to make a conversion between substance A and substance B, remember I have to go to the yellow dot first, cross the bridge, and get to the next yellow dot. And the bridge here tells me mole to mole ratio, refer to the balanced chemical equation to find this. So I'm going to give you guys practice problems where you can actually see this, and hopefully it makes a bit more sense. But that's your diagram, okay? So you can always refer to this diagram as your general direction guideline book, okay? So I went ahead and started with writing down a practice problem. How many molecules of H2O are there in 35.8 grams of H2O? Okay, and I wrote a little key. So I always start with what I know. So the question tells me I have 35.8 grams of H2O. So I'm going to go ahead and write that down right here. Okay, and I'm going to do a small little arrow because I'm going to ask myself, what am I trying to find? I'm trying to find the number of molecules of H2O. And I put that in purple for a specific reason. Okay, the reason being, when I start my table, I'm going to keep going until I finally see the words molecules H2O. These are my keywords. Once I see these words, I will stop and compute the problem. Okay? Perfect. So knowing that I start with 35.8 grams of H2O, I'm going to go ahead and write that in my first box right here. Sorry about that. All right, so that's going to be 35.8 grams of H2O. Make that a little bit smaller. All right, so remember, whenever I put down my units in the first box, I'm always going to work diagonally, okay? So the next box I'm going to work in is going to be this box right here. Always work diagonally. Now, when you're working diagonally, the units that are right here will also be the same units right here. So I'm going to have grams of H2O here as well. Okay? Why do you think that is? Well, it's because I want these units to cancel out. Okay? I want these units to cancel out. Okay? Meaning, once I multiply across and divide by the bottom, I want them to disappear. Okay, so I'll go ahead and show you what that means in 1 second. Okay, so I started right here, 35.8 grams of H2O. Okay, I want to work my way up and all the way down to atoms or molecules of H2O. So I began right here and I put that in my first box. And then I went ahead and used the units that are written right here and put them down right here. My next step tells me find the molar mass of H2O. So remember, I'm going to look at my periodic table. Hydrogen has an atomic mass of 1.008, and I have 2 of those. And oxygen has an atomic mass of 16.0. Okay, so once I find that, I'm going to go ahead and put the answer right here. Okay, so again, the units here will cancel out with the units here. Okay, we always work diagonally and we want the units to cancel out. Okay, so where am I now on my roadmap? I should be right here. Okay, the rule is when you find the grams of an element or compound, it's always going to be per 1 mole. Per 1 mole. So 1 mole is going to go on top right here. One mole will go on top. 1 mole of H2O. Oh. Now let's delete that too. That doesn't look pretty. Let's try one more time. Okay, 1 mole H2O. Okay, that looks better. Perfect. So I'm going to ask myself, where am I now? So I went ahead and stopped here. I put down my grams at the bottom, and that's per 1 mole of H2O. So I can go ahead and move on. Okay, so now this is my stop. I'm right here. I'm located right here. Okay, so remember, working diagonally, if my units are moles of H2O, what do you think my units have to be here? Yep, they have to be moles of H2O. So I'm going to go ahead and write that down. 1 mole H2O. Okay, why? Because I want my units to cancel out. Okay, so I want moles of H2O here to cancel out with moles of H2O here. Cool? Perfect. So now I'm going to go ahead and start moving down. My next stop says I need 6.022 times 10 to the 23rd atoms or molecules of H2O. Okay, so I'm going to put him up top. Cool. So 6.022 times 10 to the 23rd molecules of H2O. I'm right here. If I have molecules of H2O here, what do you think needs to come right here? Yep, you got it. Molecules of H2O also needs to come right here. Okay? However, I ask myself at this point, can I stop? Okay? I wanted to continue going, but do I need to? Well, my key tells me once you see molecules of H2O, you can stop. Look here, I have molecules of H2O. So do I need to keep going? Even though I really want to, I don't need to keep going. I can stop. Okay? So I'm going to multiply across and divide by the bottom. Now go ahead and put my answer right here. Okay? That will equal 1.196379578 times 10 to the 24th molecules of H2O. Okay, remember significant figures though. I have 3 significant figures here, and I have 4 here, and I have 4 here. So I always go by the least number of significant figures. So in this case, it'll be 3. So I'm going to round my answer to 1.20 times 10 to the 24th molecules of H2O. Okay. And that'll be my answer. Okay, so I simply followed my roadmap. I started with grams, 35.8 grams of H2O. My units here always need to cancel with my units diagonally. So I put down grams of H2O, and I went ahead and moved up to see what I needed to put exactly in front of the grams of H2O. And that tells me I need to find the molar mass. So I went ahead and computed that, got 18.02, and that's always going to equal 1 mole of the substance. And I wrote that up top. Once I reached this point, I went ahead and moved diagonally again and put down the same units, moles of H2O, before I proceeded. Moved down my road until I hit 6.022 times 10 to the 23rd molecules of H2O. I stopped here because that's what the key is telling me to answer.